For centuries, it was worth its weight in gold. People built cities to trade it. They fought wars over it. And to this day, you and I and every animal on Earth literally can't live without it. I'm talking about this. Salt! Every grain you've ever eaten comes from this, a mineral called halite that forms from the evaporation of salt water. But salt isn't the only mineral with a story. And in more ways than you might realize, the story of minerals connects to you. Hi, I'm Sage, and this is Crash Course Geology. Minerals are heroes. They make life itself possible. Some stink, some glow under a blacklight, some are magnetic, others poisonous, and some keep the shredded cheese in my fridge from clumping together. What are their more important responsibilities? But what exactly are they? Well, hold on to your bustamite. I'm about to say a lot of words. A mineral is an inorganic material with a solid crystalline structure and a specific chemical composition formed by geological processes. An inorganic material is not made from the carbon molecules associated with living things. Solid means it's neither liquid nor gas. Crystalline means the atoms are arranged in one of 6 orderly patterns called crystal systems. Having a specific chemical composition means it can be described with a particular recipe of chemical elements. And formed by geological processes means it's cooked up in nature. There are a lot of minerals out there, over 6,000 that we know of. Some are extremely rare, found only in strange or inaccessible corners of the Earth. And I bet some or even in your house right now. Like nacrolite, which you might know as baking soda. Or ice, which you might know as ice. I know, right? Ice is a mineral. But some things are mineral posers, like opal and pearl might seem like minerals, but they don't check off all the qualities in the definition. Or let me show you some other examples. Mineral oil has mineral in the name, but it's liquid. Rock candy is crystalline, but it's organic and not formed in nature. And glass isn't a mineral either. I gotta put this back in the cupboard. And we all know a rock when we kick one, but rock has a specific definition in geology speak. It's a solid made of one or more minerals smushed together. Like Dwayne here, he's granite, a mix of mostly quartz and feldspar. He's also a reminder of the vastness of geologic time and my own human frailty, which I contend with by putting googly eyes on him. So we've got some seriously cool minerals on this planet, and there are a few main ways that they form. One is when magma, molten rock under Earth's surface, or lava, molten rock that breaks through the surface, cools down and crystallizes. Another is when rock is heated and compressed so much its minerals transform into other minerals. That also happens to me when I'm stuck on a hot, crowded bus and then I transform into sweaty sage. Living things can even build minerals in their bones and shells, like one of the main materials in your teeth and bones is the mineral hydroxyapatite. And then you've got another classic way minerals form when water evaporates or cools down, creating solid crystals. That's how salt happens. It's also how filmy white gunk ends up on your faucet in your bathroom. That's mostly calcium carbonate. Some minerals just need a couple of weeks of neglecting a bathroom cleaning schedule to form, while others take a super long time with bonkers results. Like, check out these gypsum crystals, the size of trees found in Chihuahua, Mexico. It likely took nearly 1 million years to form just one of these babies in this hot cave once full of water. That's your cousin? I see the resemblance. And luckily, you don't need to go hundreds of feet below the Earth to get up close and personal with cool minerals. They're all over the planet. And mineralogists, geologists who specialize in minerals, identify them by their chemical composition and physical properties. But sometimes, this takes quite a bit of investigation. Some minerals are tricksters, con men, tough to identify. My white whale is apatite, from the Greek word meaning to deceive. And deceive it does. On the other hand, some minerals have special properties that can help reveal their identity. Like alexandrite shines emerald green in the sun, but ruby red under incandescent light. Sulfur can smell like a burning match when heated up, or take on a rotten egg stank from reactions with moisture. Calcite and dolomite fizz when they touch hydrochloric acid. And sylvite has a salty, bitter, metallic taste. So if you ever see a grown adult licking rocks, they're probably just a geologist. Hopefully. Usually, though, there's not just one thing that gives away a mineral's identity. Geologists have to examine a bunch of different physical properties to figure out what minerals a rock is made of. Let's check out some cool minerals. The first property I notice is luster, how light interacts with the surface. Some minerals are shiny and metallic looking, like this pyrite. But others reflect very little light at all, like kaolinite. This fluorite here has a glass-like luster. It's also got a lovely pale color, although it can glow brightly under blacklight. Sometimes color is a huge tell, like malachite is always shades of green, and azurite is usually deep blue. But most of the time, color alone won't tell you much. Like, quartz and fluorite are sometimes the exact same shade of purple, and depending on the trace elements it contains, quartz can also be yellow, pink, or blue. So we've also got to look at the streak, the color of the powder left behind when the mineral is scratched against a ceramic plate. Like, hematite creates a rusty brown powder. And despite its goldish color, this pyrite leaves behind a greenish-black streak. But some minerals don't leave a streak at all. That's because minerals vary in their hardness, how resistant they are to being scratched. Geologists use the Mohs hardness scale to assign minerals a hardness between 1 and 10. Talc is a 1, so soft you could scratch it with your fingernail. Diamond is a 10, so hard the only thing that can scratch it is another diamond. If you were to scratch this fluorite, a penny wouldn't leave a mark, but a pocket knife would. So I'd guess it would be around a 4 on the Mohs scale. Another property to check for is cleavage, meaning how minerals break in smooth, flat planes along weak atomic bonds within their crystal structure. Some minerals break in parallel lines, others in multiple directions. But some, like quartz and olivine, don't break in a clean fashion. This muscovite breaks into thin sheets or flakes. Up next, density. That's hard to measure in a precise way, so geologists often rely on a related property, specific gravity. That's the ratio of the mineral's mass to an equal volume of water. Geologists figure this out by suspending mineral samples in water and taking measurements. We don't have time for that right now, so I'm going to rely on the advanced technique of picking it up and feeling how heavy it is. Science! Last but not least, you can tell minerals apart by their crystal habit, or the appearance of a crystal or cluster of crystals. There's some wild shapes out there. Cubes, blobs, blades, branches, even crystals that grow like sheets or rose petals. This chalcedony has a botryoidal crystal habit, which is what makes it look like a bunch of grapes. And there you have it. Everything you need to know about that cool rock you just found. Minerals are all around us, from the cool rock you pick up outside to the salt in your pantry. But minerals are also a big deal for life itself. In the early universe, there were only about 12 minerals around, which formed in the wake of exploding stars. When our solar system burst into existence, that number grew to about 250 types of minerals. And Earth's baby years sparked the formation of over 1,000 more, thanks to weathering, the movement of water, the churning and cooling of magma, and the pressure from colliding tectonic plates. And when life made its debut billions of years ago, mineral diversity exploded. The earliest forms of life released oxygen into the atmosphere, triggering chemical reactions that created thousands of new minerals. Some living things began making minerals themselves, like we talked about earlier. Minerals created soil as bits of weathered rock mixed with decaying critters, supporting plants, land animals, and the formation of even more kinds of minerals. It was this amazing feedback loop that created a metaphorical gold mine. As far as we know, Earth is the only place life has ever formed. And if it weren't for minerals, life as we know it wouldn't exist. But also, if it weren't for life, minerals as we know them wouldn't exist. It's estimated there are 10 times more minerals on Earth than anywhere else in the solar system. And life might be one of the reasons why. Minerals are everywhere, and their past is linked to our own. Some minerals are the size of telephone poles. Others are too tiny to see with the naked eye. Some dazzle with their rarity. Others we encounter every day. Some have been part of the human story for thousands of years. And some have been around longer than life itself. Still others are lurking in the depths and corners of the Earth, waiting to be discovered. Next time, we'll ask the question, where do rocks come from? I'll give you a hint. It's when two or more minerals love each other very much. Well, kinda. See you then. Thanks for watching this episode of Crash Course Geology, which was filmed at our studio in Indianapolis, Indiana, and was made with the help of all these cool people. If you want to help keep Crash Course free, for everyone, forever, you can join our community on Patreon.